I'm in the workshop and I have a random selection of different types of flanges. The first type of flange is the blind flange, also known as the blank flange. This one is stainless steel. My stainless steel flange has markings on it, as all flanges should, for traceability. So if we're looking to comply with either, say, AS 4041, which is the piping standard in Australia, or ASME B31-3, process piping code for North America and different parts of the world, including Australia, where we're allowed to use it, or any of the B31 series, we're looking at traceability with regards to our listed components. The markings on this one read 100 mm, so 100 millimetres, T/E AS2129, that would mean table E, drilling pattern and dimensions to AS2129, and then we've got stainless steel. So a table E AS2129 flange is good for 1400 kPa at ambient temperature, but of course the pressure rating will change depending upon temperature. The key things about any flange when it's built or constructed, manufactured to a particular standard, it's all about the dimensions. So the dimensions will give you the number of bolt holes, the diameter of those holes, what bolts will fit through, the overall diameter of the flange, the thickness of the flange for a given material, and the PCD of the holes themselves, the pitch circle diameter, which is the diameter or the circle that those holes are going to be to. On this stainless steel flange, you won't pick it up on the camera, but we'll see it in the photos, we have a series of concentric grooves. The purpose of those concentric grooves is to allow, say, our non-asbestos compressed fibre gasket or our EPDM rubber gasket or our Viton or our Teflon gasket to actually take up the surface irregularities and provide a better seal when the clamping force of the bolts comes into play. So concentric grooving is a surface finish or flange facing that is quite common when we're dealing with those types of gaskets. And so our blank flange would typically go on the end of the line. We would then need to put our gasket on, bolt up, compress the gasket to give us the degree of compressibility and the tension in the bolts to provide that leak-tight joint. This flange is a slip-on flange and it has a raised face, and that raised face also has concentric grooves. So the face towards the camera is the raised face. It will protrude above the main surface of the flange according to the relevant standard. So the protrusion amount will depend upon diameter and also on rating. Turning it over, the OD of the connecting pipe comes through and sits inside this boss and is welded on the internal face, and that's your seal weld, and generally speaking, depending upon your own company standards, but more often than not, you'll also have a weld on the back face as well. So the OD of the pipe slips through and you weld around. The markings on this flange will give us the dimensions and the standard and the material. So for traceability, it's got the number 2 followed by a space and then 300. So that would indicate it's a 2-inch flange and it's a class 300 or a 300 pound rating. And then we see the next descriptor, B16.5, so that's ASME B16.5 is the standard that this flange has been manufactured to. The next series of numbers, A105, so that's the steel, so ASTM A105 is the actual material. So a raised face, slip-on, 300 pound ASME flange. I have a PVCU flange. Only 2 holes have currently been drilled out. They're just pilot holes at the moment, but there are indentations put in by the manufacturer for 2 more holes. So this would be a 4-hole flange. Looking at the markings, so just because it's plastic doesn't mean it doesn't have to be traceable. The manufacturer's name is shown on there, 50 mm, so that would indicate a 50 millimetre pipe, DN50 pipe. PN18, so the nominal pressure rating of this flange is 18 bar at 20 degrees C, and of course it would have to be derated as temperature goes up. It complies with the Australian New Zealand standard AS 1477, and that's a water industry standard. So if you work in the water industry, you would know that 1477 is the standard for PVCU. And the material itself is listed on there as UPVC. The method of joining would be that our PVC pipe, also rated PN18, would come through and it would be a cold solvent welded joint, which really means we prepare the end of our pipe straight and perpendicular, we deburr, we clean off the pipe and prepare it by applying methyl ethyl ketone as our primer, and then we apply our solvent cement, push it home to the end stop and wait for it to set. On the mating face, we also have a series of concentric grooves because PVC also requires a gasket to be used. This is a fabricated item. I've got a taper that has a 50mm connection on this end and a 65mm connection on this end. My 50mm connection is a flat face concentric groove once again, so this is stainless steel, and my 65 has a raised face concentric groove. Looking at the 65, the markings on there say 65, 16, which is PN16, EN1092, and it's 316-316L, so stainless steel is the material there clearly. EN1092. On the other side, I've got AS2129, DN50, T/E, table E, F316L, so stainless steel, table E, DN50. So what this would indicate to me is that we may have some equipment imported from Europe which the default drilling pattern for the nozzle on that equipment is to EN1092, but the local company specification or standard that is used for piping is table E to AS2129, or at least it's AS2129 with the table matching the pressure and temperature of the application. So we've gone from an imported piece of equipment to the local pipe work from then on, and this fabricated item helps us to do that. This flange here is ready for fabrication. It's called a ring type joint in terms of flanging, and the markings on it indicate it's a 150-pound 6-inch flange with a ring type joint. So you're looking at the mating surface and you can see a machined groove in that mating surface. What would actually happen, there would be one metallic ring would go into that groove per set of mating flanges, and then once the clamping force was applied to the bolts, then we would have a very, very good joint. This is one of the more expensive types of flanges because of the machining required in machining out the groove, as well as the dimensional accuracy required in manufacturing the actual ring, the metallic ring itself. But this is used for high temperature, high pressure combinations normally, or at least very high pressure ratings.